Hi, Assalamualaikum. My name is FAIZ. Today I would like to presenting for MTS3100 calculus. And I will discuss about the question 4 and question 12. I have 6 members of the group, from different classes. Okay, so for the question 4, as you can see, as soon as I accept the question, I read the question, I jot down all the information here. Okay. As question state, the rate of the altitude triangle is increased is 1 cm square, which is dH/dt, and dA per dt, which is the area of the triangle. The area of the triangle is which is 2 cm square per over minutes. And then the question is asked for the rate, or the rate is the base of the triangles. What was dB per dt, which is the rate of base of the triangle. So and also the altitude is 10 cm, which is I just think as h, and the area is 100 cm squared. Okay, first of all, area of the triangle, which is 1/2 multiplied by hb, which is height, and height multiplied by base. So as you can see, or is simplified as hb per 2 over 2, and then the area is hb over 2, and dA per dt, dA over dt equal to h over 2 multiplied by dB per dt plus b over 2 dB per dt, which is what we call product group. Okay, next, as I got this information, I will place it the numbers, the information given to the places, as dA per dt is 2, and then h times over 2 dB per dt we don't know, we need to find out, and then 20 over 2 for b over 2, and then 1 for dB per dt, and the answer we got for this is dB per dt is negative 8. So that the rate is the rate of the rate of the base of the triangle is negative 8 over 5 centimeter per minute, which is decrease, which is decreasing. The rate is decreasing. For this question, that is increasing in the rates of the height, but the base is decreasing. So next question is question 12, which is here. The question sounds like air is pumped into a spherical balloon at the rate of 20 centimeters square 3 over a second, when the radius of the balloon is 10 cm. Calculated the rate of the change of the radius and the rate of the change of the surface area. So first of all, the rate of the spherical balloon, which is dV per dt, is 20 m, and then the radius is 10 m. So in the question A, they need to find out we need to find out dr per dt, which is the rate of the change of the radius. So as you know, for the volume of the spherical is V equal to 4 over 3 pi R3 here, and dV per dt is 4 pi R2, and then dV per dt is equal to dV per dr multiplied by dr over dt here, and then we need to find out dr per dt. Thus, the operator is equal to 1 over 4 pi R2 multiplied by dV per dt. And then you find out the answer. And I put down all the information given into the equation, and it turned out to be 0.5 pi cm over a second, which is that the rate of the change of the radius is 0.05 pi cm as per second. I don't in this question I'm not converting the pi into the number, because this point it will turn out to more decimal places, and that's the answer is acceptable. Okay, for B, the rate of the change of the surface area. The rate of the change of the surface area is carried out by dA per dt, and we know that the area of the spherical is 4 pi R2. Okay, is area of the spherical area is pi r over 2. Pi r over 2. 4 pi r over 2. Don't misunderstanding about the value as this volume, this area. So dA per dt, dA per dr, yes, no mistaken. dA per dr is 8 pi r. Okay, for as we need to find out dA per dt, so dA per dt is equal to dA per dr multiplied by dr over dt. Okay, dA per dr is 8 pi r as we know here, and then multiply by 1 over 20 pi, or which is or 0.05 pi. Okay, and I insert all the information given, which is the radius in cm, and turn out to be 18 over 20 pi, and the ability is 4. Thus, the answer for the question B, the rate of change of the surface area is 4 cm squared per s over per s per second. So the answer is 4 cm. This my presentation of SL. Thanks for watching, and I hope uh, the lecturer who watched my video is understand what I'm saying, and any mistake that I have done, hope you guys can forgive me. This is the end of the end of the discussion. So my team group is doing well. So thank you. Thank you. Goodbye.